If you can see the screen, please give me a thumbs up. Okay, great. Okay, class, before we begin, any questions you would like to ask? The PowerPoint, can you see the PowerPoint? Did I share the screen? Can you see the PowerPoint? No. Okay, hold on. Can you see the PowerPoint? If yes, type yes. Class, can you see the PowerPoint? Okay, before we begin, any questions you would like to ask regarding to my previous lecture? No questions? If no question, let's start today's class. Okay, so so this is our teaching plan so far. So we have done topic 1, okay, and topic 2 and 3 we already doing it in the lab sessions and with all the additional classes on at 4 o'clock on Thursday. Okay, so this is what we are done in the lab. Okay, so that's the reason you are expected to go home and practice all this lab. So the IDE or some kind of design tools. Okay, so and then we already start our programming. Okay, we touch our C programming and we have completed the C programming chapters. And the IDE and the design tools, design tool you'll come back again, in the final chapter. So basically this one is talk about all these in-circuit emulator, oscilloscope, to doing testing purpose. Okay. So topic 4, topic 3, we'll run this, we'll learn this through the lab sessions, the integrated design environment, which is the MPLab X, and as well as micro U vision. Then we are into microcontroller-based system, okay, where we are going to look into 8-bit microcontroller, 16-bit microcontroller, as well as 32-bit microcontroller, which is a ESP32. Okay, so so in this chapter we'll look into different type of microcontroller in the market. So and we are go deep, into the features of some of the microcontroller, especially PIC24, FJ, and ESP32. Okay. So as you know that most of the microcontroller in the market got all these features with built-in ADC, DAC, I2C, SPI, UART, watchdog, timer, interrupt, PWM, power width modulations. Okay, so and you will go deeply, in the I2C, SPI. Okay, and I believe that you already learned timer and interrupt in the lab. We will start watchdog timer today. Okay, so basically all the fundamental components in a microcontroller are the same. Okay, they have a input-output port, a built-in memory. Okay, so and then all these things are integrated into one small tiny IC. Okay, so those days, 8051 family microcontroller is very popular. Okay, especially AT89S 8252, and now they are already updated. They are just improved their memory through what I call that. Improve their memory and name it as AT89S8253. So a lot of people, in the market are saying that microcontroller are going to die. But actually, it's still not true. Okay, even though the booming of ESP32, the booming of all these advanced ARM microcontroller, but those days microcontrollers still in the market. Remember this. Okay, so why I say so? Just for example, let's move on to this. Let's type AT89S8252, 8253. Okay, and AT89S8253, the price is about 11 ringgit. Why so expensive? Okay, in RS it sell about 12 ringgit. Okay, it's about 12 ringgit if you purchase per pack. Per unit is 12 ringgit, and per pack is about one pack about 20 units. If I'm not mistaken, it's about 60 over ringgit. So although this chip is definitely can say is more expensive than ESP32 microcontroller by itself. I'm not talking about a development board. I mean, I'm talking about the microcontroller itself. So even though this microcontroller still in production, okay, still in production. Remember, Atmel, is already bought over by Microchip. Okay, so it's good, to understand some of the features of 8051 microcontroller. For information, Kampa, Kampa is learning 8051 family microcontroller under the subject embedded system design. You can contact with your friends in Kampa for EE student. Okay. So there's those days also got something more advanced microcontroller. 80C517 is under Infineon. So the only difference is they have more input output port. Okay, but however, this kind of chip is not come in dual inline packaging. They come in a PLCC type. Is like a surface molding type. Okay, so class, remember MCS 51 family microcontroller already exists in the market in early 80s. Before you are born. Okay, in early 80s. Okay, like ESP 8266, ESP32, it just happened in the market in year 2000 plus, So that's the reason this is what we call that 80517 or MCS 61 family microcontroller are the old generation of microcontroller. So therefore, you can find a lot of reference book, in the market, and they are very well established. They're very stable. Okay, this is what I want to say to all of you. So then, of course, things are changing nowadays because due to the mobility, due to the low power market, and due to the handphone market, microcontroller is come into play. So there are three different types of processor in the market. One is a Cortex-M, one is Cortex-R, one is a Cortex-A. So Cortex-M basically is a small footprint, lower power microcontroller. Okay, they are built-in DSP, digital signal processor, into the microcontroller so that they are performing mathematical calculations, or processing imaging easily. Okay, whereas if this is just a microcontroller itself, they are very weak, in doing mathematical calculation like 14-point calculation. But this is solved by the Cortex-M processor. So Cortex-R processor is a bit high performance. Okay, so both of these processors normally is built in, can run using RTOS, real-time operating system. So for more advanced ARM microcontroller is a Cortex-A processor. So they're always built in a rich OS, means that you can install Microsoft Windows, Linux into that particular platform. Okay, example of Cortex-A is a Raspberry Pi. Okay, so here are the market. Okay, here are the timeline. Okay, and the types of microcontroller and ARM microcontroller in the market. I'm not going through details over here. And of course, the normal Cortex microcontroller, the most popular one is a M4, Cortex M4. This is the one pre-built into the nuclear development board under STM microelectronics. Okay, why this is so special? Because they got built-in DSP, okay, with a single instruction multiple data. So this means that one instruction can carry few tasks. So I believe that most of you already learned this under the subject computer architecture. And of course, they also built in a floating point hardware. So this why Cortex M4 is so unique. Okay. So here are the example of the nuclear board. So if you're interested of using this board, you can learn this, from the lab. Okay, we got a limited unit. We got about 5 units. Okay. Here are the layout. Okay, class. Remember, you see, when we come to embedded system design, we are not just studying the board. We are looking into the microcontroller itself. Let's say, for example, the nuclear board. They are using the microcontroller STM32F411IET6. Why it's important to learn the microcontroller? Because you are the one who's going to design this board. Okay, just to share with you. So those days when after I graduated from university, so I'm going to work for a while. Then I set up a company and developed a development board called FXX031. Okay, so FXX031, just to share some of the information with you. Okay, this is a development board. The development board itself, okay, got two microcontroller. Okay, I'm using AT89S8252. Okay, two microcontroller. This one microcontroller 1, microcontroller 2. Okay, it's a development board with built-in LED, and there's a port. All the port. Student can insert the input-output port, and we link to the PC through the UART. Okay, means RS232, the old type of communications platform, 9-pin. Those days when you're using serial port connector. Okay, so what I did at that time, I developed this board. I designed the whole board. Okay, so the microcontroller 1 and microcontroller 2 are linked through SPI. We're going to learn SPI later. Okay, so my target firmware are logged into the microcontroller 2. Student can download the code into the microcontroller 1. So basically, microcontroller 2 is take up all the hex code that is downloaded and doing a processing and send all this hex code, into the target microcontroller 1. Okay, I hope you got what I mean. So at that time, I'm developed this using Delphi. Okay, because those days Delphi is faster than C programming. I'm not sure why Delphi is already not popular in the market. Okay, you can have a look, Delphi programming. Okay, my time that was in year 2003. Okay, so we developed using Delphi. The whole development tool ID is using Delphi. Okay, so for information, with this I sell it to Mara. At that time, with all the reference manual, is about 1,200. And for information, Utah also purchased for me, Utah and Thai UC. Okay, so yeah, I sell them is about 500 ringgit. Just imagine, you see, that board development is not only go into industry life. Okay, it also can go into the education. So if you are good, you can sit down, you can develop some nice development board. Like for example, you can use ESP32. You can create your own development board as well if you understand details about what is going on in this microcontroller. So this is our journey. I will teach you how to look into the microcontroller that lead you to design such board. Okay, let's move on. Okay, this is a layout of a nuclear board. Okay, so for information, they got different type of microcontroller in the market. Okay, like for example, this one is a low pin count, is under Philips those days. It's now NXP, and this is a very popular microcontroller because they say it's a low pin count. Although they got a lot of function, but the number of pin is not as many as like 80C517. This one got so many pins, got 128 pins, for example. So the same features, but they limit the number of pins. So that's why the size of the microcontroller is quite tiny and small. Okay. So, but all the informations, in this.
I can't do that yet, but I'm working on it.
Sorry, my Samsung phone. But of course, this kind of microcontroller is very popular in the market because they built in ARM Cortex M3. Okay. So this means that ARM Cortex microcontroller, okay, the proprietary is given, out to a lot of manufacturer, not like microchip. Microchip, just microchip. Like ESP32. ESP32 is not using ARM, they're using their own microcontroller, using their own chip called Extensa chip. Okay, so let's move on. Okay, so in the market, there's a booming is when it comes to Raspberry Pi. Okay, remember Raspberry Pi is started with education's package. They are not started with industrial package. Okay, just recently they try to move into industry. They try to penetrate through the industry market. Okay, so remember, Raspberry Pi is not microprocessor and is not microcontroller. Raspberry Pi is just a small single board computer. So normally Raspberry Pi is just a computer. It's a small tiny computer. So if you don't have you are not rich, you not afford to purchase yourself a laptop, actually you can get a Raspberry Pi, hook into the mini monitor because they already built in HDMI. Just hook into the monitor, and then with the keyboard ready, plug in the USB, and with the mouse, okay, you can already have a mini computer. So that's the reason Raspberry Pi is quite popular in the market, because due to their powerful features. Okay, you see the latest Raspberry Pi is become more and more advanced. Okay, it's just like you're following the trend of phone, you know. 2 years ago, Raspberry Pi 3. Now got Raspberry Pi 4. Then next year got Raspberry Pi 6 or so on, you know, and they're getting more and more powerful. It just imagine, will the market ready for all these powerful devices? Okay, so for information, like for example, if I purchase 8051 microcontroller, it can be used until today's. After 20 years, it's still good, you know. Okay, just imagine if I ask those old company, old factory to upgrade to using Raspberry Pi 4, it's a big headache, you know. There are a lot of money is involved, you know, in this big process. Okay, and of course, upgrading of system is not as easy as you thought. Okay, migrating as well. Just like for example, you are facing difficulty to migrate the program of PIC18 to Micro U Vision of to MCS51 family or to ARM microcontroller. Okay, so here are some of the features of Raspberry Pi 4. Is very interesting, and this is the old generation of Raspberry Pi. Raspberry Pi 1, 2, 3, 4, and we also got a Raspberry Pi 0. Okay, so this is some of the evolution of Raspberry Pi. Okay, basically this is just a mini computer. Just for information, I'm not going through details on this. Okay, and the price is reasonable. It's not expensive. Okay, and of course, here are the differences of Raspberry Pi 4 and Raspberry Pi 3. Okay, so and of course, they are more HDMI, the faster, the microprocessor. Okay, because they are using Cortex A53 to A72. It's just like your iPhone, you know, iPhone 9, iPhone 10, iPhone 11, and just like Huawei 10, Huawei 11. All this is just what I call that. It's just a market to. It's just how we follow the market, you know, to have a better features of products. Okay. Then of course, when it comes to ESP8266, it's same. So ESP8266 is introduced in 2014. It's very tiny and very small. They got a lot of variants of ESP8266 at that time. And for information, at that time, Expressive, you know, come out with ESP8266. They are planning just to target a small group of market. And you also don't know that, you know, ESP8266 become booming. Why booming? Because due to it's very cheap and you are able to have a Wi-Fi, if a Wi-Fi module itself. Okay, so Expressive become from a small tiny company become a giant company nowadays. Okay, for information, Expressive is from China. Okay, you can hook into their website and have a look. So then here are some of the features of ESP8266. And remember, ESP8266 is introduced in 2014. Okay, then later ESP32 is introduced in 2016 or 2017. Okay. So what is so unique about ESP32? Because ESP32 itself already built in CP2102. What is CP2102? CP2102 means that I can directly connect, you know, my ESP32 through USB port, you know, okay, to my computer. But however, those days when you use ESP8266, you are not allowed to do so. You need to have a middleman. Okay, so the middleman means they have to convert the the UART to USB, okay, connections. Okay, so this means that you need a special tools, okay, like special tools to communicate between the ESP8266 to the computer. Okay, so example, like if you are, I'm sure that you heard about ESP32 cam. So ESP32 cam is another variant of ESP32 which built in a camera. Here is how it looks like. Let's come back to our class. Let's switch on our camera. Okay, so here is some of the platform, some of the development board of ESP32 cam. It comes with the camera. Okay, so but however, this ESP32 cam is not allowed, to communicate directly to the computer. So you need FTTI. So FTTI basically is just USB to UART communication. So basically you need something like this, okay, to communicate to this particular development board. Okay, this is exactly same connection as what I call that for the ESP8266. Okay, is it okay so far? If yes, give me a thumbs up. So any questions so far, class? Am I going too fast? Okay, so let's come back to this. Okay, so there's a lot of variants of ESP32 as well. Okay, so here are the comparison between ESP8266 and ESP32. Definitely you will go for ESP32. Why? First, you do not need FTTI. You directly connect, your microcontroller to USB. So basically, what is FTTI? So for your information, microcontroller, we got a UART. Okay, we got transmit, receive. Okay, so your PC nowadays they don't have UART. Even though you got UART, those old days, you got old computer, you got UART. Mean they name it at RS232. It's something like this. Like I told you just now, 9-pin connector. Okay, 9-pin connector. You can transmit, receive. You go to the breadboard, receive, transmit, just like transmit to receive, transmit to receive. If you connect like this, and assume that PC got a UART, okay? Okay, if you connect like this, you will burn the ESP8266. Why? Because ESP8266 just run at 3.3 volt. However, in the PC, it's about plus minus 25 volt. Okay, so just to share with you, in PC, okay, so for the positive region here, 3 to 25 watt is considered as binary 0, is not 1. And -3 to -25 actually is a binary 1. Whereas for ESP8266, okay, 0 is 0 volt, is about 3.3 volt, therefore, of course, there's a threshold value. 3.3 volt is considered binary 1. So that's the reason 25 watt cannot share with 3.3 volt. So therefore, you need a middleman. So the middleman is something called FTTI, okay, to do the conversion, to do all the conversion for you. Okay, I hope that you understand. But thanks to ESP32, it comes with CP2102. It means that this CP2102 already do all the jobs for you. You no need to worry what is going on. Okay, and moreover, this ESP32 is built-in voltage regulator as well. Okay, so but if you are like to do imaging, okay, you want to get a cheaper board to do facial recognition to recognize object. ESP32Cam is a very interesting choice. There are a lot of library out there. You can have a try, but remember you need an FTTI. Okay, you can't just simply connect ESP32Cam directly to your PC. Okay, let's move on. Okay, here are the difference between ESP32 and ESP8266. I'm not going details on this. Definitely ESP32 is better and more powerful. Okay, let's jump to the ESP32 slides. I hope everything is okay. Okay. So class, remember ESP32 is not the microcontroller. What microcontroller or what is the microprocessor or microcontroller used by ESP32 development kit? Actually, the name of that microcontroller is this, is the WROOM32. You got all this data sheet, this one. Okay, it's a WROOM32. These are the microcontroller. These are the features of this microcontroller. Remember class, whenever ESP32, okay, so and then you can the microcontroller that used is a ESP32 D0WQ6. Okay, so this is the microcontroller that is used under your ESP32 WROOM32. Okay, these are the microcontroller. So it's important for you to understand the microcontroller features, whether it's an electrical characteristics, whether what features is given to you by this tiny microcontroller. This is very, very important. Why? Because in future you might develop your own development board. Okay, so for your information, of course, like ESP32 development board is very cheap in the market, but you must remember you can make it cheaper. Okay, and it's made in Malaysia. Okay, and have more features. You can always put in more features. Like for example, what are the problem in this ESP32? They don't have some indicator. They don't have I2C extension. All this extension board. So you can build all in one, just for sharing. So, but in order to know more details about this chip, you need a data sheets. Okay, you need to understand details on all the features that's available in this microcontroller. So this is very important. I'm not going details on this. So that's a reason data sheet is your best friend. Okay, in order to penetrate through to understand the details of each microcontroller, you need to read the data sheets. Okay, so here are some of the example of the data sheets of very important data sheets that you need, okay. Okay, let's move on. Okay, so another thing, so since we are not, looking into ESP32, we are not looking into the microcontroller under the ESP32 section. So we are using the development kit. Okay, so why we are using a development kit? Because the reason I'm choosing ESP32 actually is to understand, let you understand the simplicity of ESP32 development board. It's not difficult at all, first thing. Secondly, he can perform Internet of Things, you can doing an Internet of Things or Wi-Fi related project very easily. Okay, so here are some of the development board available in the market. And for information, the cheapest is a ESP32 Do It kit. Okay, that's a reason, I'm choosing this. But based on my research, if your financial is okay, the Spark Fun ESP32 thing is the best so far in the market. Okay, because it's come with a battery charger. You can basically power up your mouse controller just through a power bank. Okay, and you also got. Okay, is it all right, class? Okay, here is some of the features of ESP32 that you have with you once you purchase it. Okay, basically these are the main processor. Okay, the built-in reset button, boot button. Okay, it's basically it's a very simple microcontroller, and all this I/O connector actually is linked underneath to this microcontroller. Okay, I think it's about 40 pin. Okay, it depends which variant is it. Okay, basically other features is quite straightforward. Okay, so and as you know that in 2019, Expressive come out with the newer version of ESP32. He called it as a ESP32 second edition. Okay, so basically it's faster. It's faster, but it only has single core. But remember, ESP32 have two core. Dual core. The one we are using now is dual core. This is single core. Okay. So of course, the clock frequency, it looks quite similar, but the processing is faster because they're using LX7, the newer version of microcontroller. So however, all the features are more or less the same, but they are removing a lot of things in ESP32S2. Okay, probably they try to reduce the cost. Okay, like for example, some of the sensors feature is no longer support, in ESP32S2. Example, Hall effect sensor, don't have. Okay, but however, the built-in like USB OTG, LCD interface, camera interface, all these things are built into the ESP32S2. Okay, so this means that ESP32S2 is not to kill the ESP32 market, but is to kill the ESP8266 market. But for your information, all these, even though it's ESP8266, ESP32, and ESP32S2 is considered very new in the market, so it's not likely they're going to penetrate through to the world industry. But yes, he might penetrate through to the automation world because it's so cheap. Okay, probably in China. Okay, so it become more and more popular basically, and then of course, I believe that they got high potential to penetrate through to the industrial market. Okay, so here are this is the one we are using, if I'm not mistaken, the newer version of a ESP32 development kit. Okay, there are few versions. No, this one, variant 2, Utah version. We are using this 30 GPIO. They got 30 GPIO input-output bit. I think this is slightly more expensive. If I'm not mistaken, you can visit this ESP32net for more details. Okay, so here is some of the photo of a SparkFun32. Okay, if you're interested, you can always get this board as well. There's a lot of library, for SparkFun32 thing as well. Okay, here is some of the features. Okay, so basically, come back to the same question. Okay, for your information, you are learning PIC24 FJ64GS002. PIC24 do not have a development board. So that's the reason those days your senior build their own development board. So basically, it's not difficult to build your own development board through PIC24 FJ64GS002. Okay, let's say one day you are asked to choose a board. Okay, your company said that, oh, PIC24 FJ64GS002, my engineer built all these things, it's very, very troublesome. Why don't you get them a development board? Okay, same as ESP32. Either you want to purchase a development board or you purchase a chip. Normally for industry, they purchase a chip. They're not going to purchase a development board. Okay, they purchase a chip and then they develop themselves, or they ask another company to develop the development board according to their needs. Okay, so how to choose the board? First, the GPIO pins, to make sure that that particular development board can access all the pins. Let's say, for example, okay, got 36 pin here. Is it access all the input-output port that are available in this microcontroller? Okay, that's a question you always ask. So secondly, it's easy for prototyping and safety features. Like for example, we don't have it's well protected. is well regulated. Okay, so all the USB serial, all these things already built into this particular development board. So example like ESP8266, I'm not going to waste my money to buy another FTDI. FTDI, you can have a look. FTDI, you know, in order to connect my ESP8266 to my computer. So then easy debugging. We got built in all the boot button, reset button, status LED, you know, I can blink the LED to check whether that particular microcontroller alive or not. So all these things should be inside the development board. And easy interfacing. Like for example, ESP32, the one we bought, we cannot interface with the battery. So like SparkFun, you can interface with the battery. So therefore, if my financial is allowed, I will choose SparkFun. And sometimes the add-on features like camera, LoRa module is built, everything integrated in one development board. Okay, so if everything is in, why don't you go for the development board with more features? Okay, let's move on. So here are some of the final comparison of ESP8266 and ESP32 that we have. Okay, so basically ESP32 is very, very useful. Why? They built in a lot of things. Built in Bluetooth, touch sensor, everything. You just name it. You know, CAN bus, almost everything is in there. Indeed, in this small tiny chip of ESP32. Okay. So, for information, when you look at ESP32 development board, they got a lot of variants. So the one we are using is this one. Okay, this is a WROM 32. Okay, this is the chip that is embedded into your development board. Okay, so you can check whether they are dual core or not. They should have a D. D means that they are dual core. Okay, this is just SoC packaging. Okay, so if you want to know more details of your ESP32 chip, please look at these data sheets. Of course, the ESP32 do it is using this microcontroller. Let's move on. So let's open up the ESP32, and remember this ESP32 is not the development board. We open up the chip. This is we open up this chip. We open up this chip. We dissect this chip. So when you open up this chip, this is what is inside this small tiny thing, WROM. You know, this rectangular means is this one. Okay, all is inside. Okay, by using the soldering style, we can connect all the input/output pin, to your development board. Okay, let's move on. Okay. So you can see that there's a lot of things are built in. So one of the most interesting things, that cannot find in most of the microcontroller nowadays, okay, is a cryptography hardware acceleration. So what does it mean by this cryptography hardware accelerations? When you're dealing with when you're dealing with when dealing with IoT, when you're always doing wireless communications, security is one of the major concerns. Okay, so the good thing of ESP32, they're built in the hardware cryptography. So you can use AES, RSA, SSA, and ING to protect your system, okay, from being hacked in. Okay, why this is important? Let's have an example here. Okay, so this is a security issue. You can go on this website and check. So when it comes to IoT, security is one of the major things. Okay, if the hacker able to hack into your system, if the hacker able to hack into the ESP32, let's say for example you are the user, you got heart problem, you got pacemaker is using the ESP32. So this means that a hacker can stop your heartbeat. Okay, it's very dangerous. Okay, he can hijack the pacemaker which is installed near your heart. So there's a lot of problem. Let's say I want to unlock and lock my door using my handphone, and it's pre-built IoT, and there's a using ESP32. If you don't have a proper security, they can take control of your car. Okay, they can stop your engine. Okay, they can suddenly switch on your TV while you are sleeping at home. Then your parents say that you got ghosts in your house. So all these things is very, very risky. So due to this, the interesting is ESP32 already pre-built hardware acceleration. You protect, all these unwanted problem. Okay, let's move on. Okay, so for information, ESP32 is come with two cores. One is a protocol CPU or Pro CPU. One is an application CPU. Okay, this is what we call a protocol. Okay, so for the protocol CPU, it always normally is handle all the Wi-Fi, Bluetooth, internet peripheral like SPI, I2C. Okay, whereas application code is handling your application, your code your applications. And class, the interesting is both processor map symmetrically the memory location. Okay, they got two core, but they're able to map the memory location symmetrically. They are sharing the same resources. Okay, so this means that they are able to map symmetrically the memory location. Okay, this is one of the very important things that you should know. Okay, so of course, this is done by ESP IDF. IDF means that IoT development framework. Okay, you always this is just a name. So they got a team. Okay, they got ESP IDF. ESP IDF is a IoT development framework. Okay, you can hook into the Expressive website to know more details about this. Okay, so here are the internal memory of ESP8266. There's one error over here. So it's your job now to find that area, that error. Okay, the error is this. Can you tell me the answer? So for booting, using 440 KB of room. Where is the room? The room is over here. The location is from here and here. Can you tell me that this is how many KB? So I enlarge this. So basically, the address from the first location is from 0000 until FFFF. And from the location, okay, class, all these things you learn under the digital class. So if you don't know how to calculate this, means you are in, I'm not sure. Okay, can you tell me that what is how many KB? How many KB? How many kilobyte? Someone, can you use a calculator and calculate and try to verify it? Is it really 440 KB? Yes, anyone from the class? Yes. What is the size of this booting ROM instructions and core function? How many? What is the size of this ROM? Why this one like this? So anyone? So whatever your answer will be recorded. What is the size of this ROM? Okay, so quiet. So if you don't know, say no, don't know. Yes. Okay, class. So basically it's from 000 until FFFFF. Okay. So here is how many bits? 4444 is 16. So 00 until 6FFFF means is starting from 0 until 65535. 16 bits. So basically here is a 65536. So got 65536 over here plus. Okay. So if 5FFFF, okay, start from 0 with +1. What is this value from a calculator? Okay, let's punch a bit. Okay, based on my calculation, this should be 393216. Okay. So therefore, 65536 plus 39216 is equivalent to 458752 locations. Okay, for the 458,752 locations. Okay. So convert to kilobyte, you just divide by 1024. So this is equivalent to 448 KB. So this should be 448. Okay, is it okay, class? I hope that you know this, class. This is a fundamental question being asked, during one of the interview of my student in Intel. They give you a memory map. They ask you to calculate, how many KB. So if you are not able to calculate, means that you are not qualified, to go for interview in Intel. Okay. Why 5FFF? Let here. According to the memory table, let me enlarge this. Internal ROM is shared from 3FF9, FFFF. Another location is 00 until FFFF. Okay. So that's the reason is 5FFFF. Okay. So class. There's a this memory location is from, because this is 32 bits. It's a 32 bits. So there's a lot of features inside this design. So let's briefly go through this. Okay. So first we have the bootloader. This is ROM bootloader, internal ROM. Okay. There are something called RTC fast memory and RTC slow memory. So RTC means real-time clock. So real-time clock slow memory is used by the ultra-low power processor in the deep sleep mode. Because in ESP32, we got something called deep sleep mode. Okay. Same with PIC24, we also got something called deep sleep mode. Okay, remember this, they got difference between idle mode, sleep mode, and deep sleep mode. You rarely sleep deeply. But however, sleep deeply doesn't mean that you are dying. Doesn't mean that your microprocessor is not functioning. Let's say, for example, you are sleeping at night. If you're deep sleep, don't tell me that your brain is malfunctioned. Okay? But during this sleep mode is enabled, the real-time clock is still running. Okay, it's still running. Okay, so this sleep mode actually is just to reduce the power consumption by disable the main core. Okay, remember this. We also got something called RTC fast memory. Okay, so again, this one is even though the core is in sleeping mode, okay, I want to ensure that the CPU, this one, to ensure the CPU can access the data safely during the deep sleep mode by the ultra low power features. So this means that you are in deep sleep mode. Suddenly got some data is coming in, you're still able to manual this data, still able to handle this data. Okay. So basically RTC fast memory is for data storage. Okay, is it okay, class? Okay, so basically these two features, this memory location allocate, okay, RTC fast memory, RTC slow memory, is used during a deep sleep mode. Okay, I hope that you know what is deep sleep mode. Okay, you can calculate how many memory is have been allocated for these two devices. Okay, so another thing also, so 500K SRAM for internal RTC 16K. 16K, you can calculate whether it's correct or not. Is it 16K? Okay. So we also got 1 KB eFuse with 256 bytes of MAC address and chip configuration. So here is it. So for your information, actually, each ESP32 or each network card that got a unique MAC address is being reserved. Okay, it's reserved, and the 256 bytes is reserved for these features. Okay, what is MAC address? We discussed it. We discussed this clearly when it comes to the IoT section. Okay, so here are some of the arrangement of external memory. We can maximum up to 8 megabyte of SRAM and 60 megabyte external flash. Okay, so can you tell me what, based on this memory map here, what is the address space? What is the total size of this? What is the size of this? Here is a 32 bits. So it's 2 power 32. So 2 power 32 is 2 power 10, 2 power 10, 2 power 2. All right. 2 power 10 means K. Another 2 power bit is MAC. So it's about 4 megabyte of memory. Okay, 4 megabyte of memory. Okay, 2 power 10 is 1K. 2 power 10, 2 power 10 is 1 meg. Okay. Remember, it's different. 1K is 1024 bytes. It's not 1000. There's kilo. It's two different things. Okay. So this is a Wi-Fi protocol. I'm not going details on this. This is a 7-layer. Okay. So basically, he can support most of the protocol in the market. So when you can support most of the protocol in the market, means you're already compatible with all the Wi-Fi router in the market. Okay, so from MQTT, Core App, all these things is for the IoT protocol. It's IoT protocol. Okay, so and the interesting point is the ESP32 can be an access point, can be a station mode. Devices also can talk to the access point. Okay, so I believe you know all these things. So in ESP32, if in a deep sleep, he just take about 7 microampere only. Okay, you can calculate if I power this using 2000 milliamp of power bank. Okay, in deep sleep mode, again, how long can it survive? Okay, how many days can it survive? Okay, you can calculate all this. Okay. So we got Bluetooth as well. We got Bluetooth Smart and Bluetooth Classic. We support both. Okay. So I'm not going to all the features of Bluetooth over here. So security, and then the security just now I already told you that. So it's very important, the security features, in IoT product microcontroller. So nowadays, most of the microcontroller that have IoT features, means Wi-Fi features, they're already built in, hardware security. Okay. So when you come to development platform, so for ESP32, we definitely using Arduino IDE. Actually, got so many different platforms out there. You can have a look. If you are adventurous, you can go to Espionor, Mangos OS, all these things, okay, Eclipse, all these things you can communicate with your ESP32 ESP32 development board. So of course, under this subject, we're using Arduino IDE because most of you are quite happy, quite familiar with Arduino IDE. Okay, so for the programming part, definitely you got definitely it's Arduino IDE. I'm not going through in details of MicroPython, JavaScript, or Lua. Okay, so because we are still using back Arduino IDE, so Arduino IDE is more alike as a C programming. Okay, so how to install, later we come back to our main slide. Okay, any questions so far, class? Okay, we have a short break of 5 minutes before we come to something more interesting. Let's check. Ying Hao is a memory. Yes. Okay, 1 bit. Okay, very good, Ying Hao. Okay, recorded. Class, you may ask questions if you got any problem. Yes. Okay, come back at 1:05. So any questions so far from the class? Chunkit, what do you mean by how to know which protocol ESP32 is using? Hi, oh, okay. Okay, welcome back. Okay, now we move into more details about PIC24. Here are the main reference tags, for PIC24. Okay, you can get this from the library. Okay. There's a lot of info in this book. This book is it's not a new book. And in this book, I think he's still using C30 compiler. Okay, so remember this book is not a primer on C language. But anyway, whether it's a C30 of X30, X16 is just the same. Okay, so actually I say not cover, but we will still change notification. We still look into it. So in this book, they also discuss about video signal. You link it to monitor, to touch screen. Okay, some audio signal. By audio signal, you can do audio processing and mass storage. You can link to hard disk, to the PIC24 microcontroller, as well as SD card, micro SD or normal SD card. So all these things we don't have time to cover. So if you are interested, you can always come to me to discuss further. So there's another book. This book is more readable, okay, compared to the book just now. So so remember, all these microcontroller books is not cheap, but however, you can get it free, from a library through ebook section. Okay. And class, just to share with you, they got plenty of microcontroller book in the market, but not many is on the ESP32. Okay, in this book by Lucio, he's using PIC24 FJ 128 class is more or less the same. So F and H, F is a slower version, H is a faster version. We'll look into this later. Okay. Let's look at the PIC24 family comparison. Okay, so of course, you already learned PIC18. PIC18 is about 10 milli instruction per second, is slower, but however PIC24 is faster. Things you're getting faster and faster when you come to PIC24H, high speed, 40 milli instruction per second. And we got DSPIC as well. So DSPIC, you got a DSP features. I thought about features only, features or DSP features inside this microcontroller. Okay, here are some of the identification of microchip. So GA, is general purpose, and you can support quite enough come with quite a big memory size. Okay, I mean 128K, you consider is a very large for this 16-bit microcontroller. And this is a PIC24F. Okay, so PIC24F is the one we are using. Okay, so remember PIC24F, they also come with a lot of variants. The one we're using is PIC24FJ64GA002. Okay, you see the one with the red color one, USB OTG. So USB OTG only be supported by GB. Okay, GB versions only can support the OTG, USB OTG. Okay, what is USB OTG? I believe that most of you heard about the word OTG. So for information, USB normally come in two different kinds of endpoint. One is a client, one is server, and sometimes they call it host, correct or not? So when we say OTG, that particular microcontroller can be a host, can be a peripherals. So this means that this microcontroller, let's say if PIC24FJ64GB002 if you use, you enable the OTG. Basically, I can this particular microcontroller can detect your pen drive once you insert your pen drive, into this PIC24 FJ64GB002. So basically, it become a host. Okay, so those days, microcontroller is just a peripheral. He can't detect your pen drive. Okay, he can't. He just transfer file, to the host, but he himself is not a host. Okay, I hope that you know what is OTG. So this means that when you come to OTG, it's just like a handphone. Your handphone is a bit different. Handphone it can be a peripheral and can be an OTG. So you want the OTG, you need a special cable, correct? So basically, if you talk about OTG, there's one additional pin, to your micro USB socket. Okay, but of course, your microcontroller must have that features to support OTG. So remember, GB is support only GB, variants can support OTG. Whereas a PIC24 Edge means it's high speed, is faster. Instead of 16 million instructions per second, it can go up to 40 million instructions per second. It definitely is faster. Okay. Let's move on. Okay, so here are the difference between the PIC24 Edge and F. The difference is 60 megahertz and 40 megahertz. So that is a major difference. Okay, so whereas for Internet FRC, okay, it's 8 megahertz and 7.37 megahertz only. So why we choose PIC24F? Because it just have two configuration bit, config 1 and config 2. Whereas for PIC24 Edge is 6 configs. Please be aware. Okay, so here are some of the pin out of PIC24 FJ64G002 and HF. Okay, so let's briefly go through all these pins. So first we have the master clear. Basically, this is reset. And pin number 2, and they are sharing about analog pin. It can be an analog, it can be an input output pin. Okay, so this also can be a V reference plus and V reference minus for the sometime for the comparator function. So class, remember they got big microchip got one very interesting feature which is called CN2 and CN3. Okay, CN2 and CN3 means change notification. So change notification is another type of interrupt. Okay, like another type of external interrupt. So it means that if I say that if change notification can be high to low, I can trigger the interrupt. Low to high can trigger the interrupt. So what does it mean? So change notification means that you can trigger the interrupt if they have a transition, if they got transition from high to low or low to high. Okay, is it all right? This is a very simple explanation. So this means that sometimes you're running out of interrupt pin. Like for example, where's the interrupt pin? The interrupt pin is not in here. So running out of interrupt pin. So that's a reason we can use change notification, to replace the interrupt. But remember, change notification is got a bit of delay, and when the interrupt is being triggered. Okay, and moreover, high to low or low to high also can trigger the interrupt. So this is one of the major disadvantage. Okay, so another interesting feature of CN2 and CN3 is this. All the CN, all the CNX class. Please look at this carefully. CNX, you can link it to something called CNX PUE. Okay, so this means that if I'm writing this, CN2, this 2 means this pin, PUE equal to 1, automatically I'm activate the internal weak pull up resistor. Okay, can anyone tell me what is a weak pull-up resistor? Anyone? What is weak pull-up resistor? Weak pull-up resistor means what? Means the resistance is relatively very high. Okay, that means they have a very high resistance, okay, inside this particular pin. So this means those days, let's say for example, RA0, I connect, normally we connect into, let's say, 3.3 volt with a pull-up resistor, let's say, I don't know lah, okay, and you guys are always using 10K one, correct? I also don't know why you want to use 10K. So let's say this is a switch, okay, normally it's high, okay, or I connect to the keypad, the keypad 1, 2 keypad, okay, so all the keypads should have a pull-up resistor. So, but once you activate this CNPUE, you can already ignore this resistor. Why? Because it's already enable the internal weak pull-up. So this means that we save one resistor. Although resistor is very cheap, few cents. If you have a mass production, you produce 1 million design, means you save 1 million cents. Okay, so this is a very interesting features of PIC 24. Okay, where other microcontroller also don't have. Okay, you got something called internal weak pull-up resistor. So please be reminded, only for PIC 24. Okay, so where is this pin? Okay, keep this. You can always come back to the data sheets, okay, and just find this whether it exists or not. CN PUE or PUE. Okay, it's here. Where is rotate? It's here or not? So here are all the CNPUE resistor. Okay, so they got 15 pin, CN 0 until CN16, CN30, 29, 28. So all these pin, you can enable the internal weak pull-up resistor. Is it okay or not, class? If okay, give me a thumbs up. Yes, is it okay? Everyone, are you listening? Okay, very good. So you come back to our lecture. Okay. So it's quite interesting, the internal weak pull-up. Okay, so then we just move on. Okay, we got something called P. So this V reference and V reference minus also used in ADC. Come to that later. This one, PGD and PG1, all these things are for link to your PIC microcontroller, PIC 2 or PIC 3 or PIC 4 is for programming purpose. Okay, so for programming purpose. Okay. So another interesting thing is this RP. RP means that it's called a remapping pin. We will come to that later. So this means what? Do you notice that PIC 24, you can't find external interrupt? Can you find this word inside here? External interrupt. Got external interrupt one example. One got external interrupt is here. Don't tell me, this microcontroller allow you to have only one external interrupt 0. Can you see any other than INT 0? Can you see INT 1? If you can see INT 1, please let me know. I will automatically awarded you 10 marks. There's no INT1. Why? Because PIC24 is a very flexible chip. I can assign my INT1 anywhere whenever they got RP. This is called a remapping pin. Let's say, this is very useful. Let's say I'm soldering this board, this microcontroller into a PCB board. Suddenly, all this side is being blocked. I cannot install. I cannot connect to the interrupt pin. Okay. Let's say INT0 already blocked. I can't install INT pin. But however, I can always remap this. Oh, I want this to become INT1. Oh, I can want this to become INT1. Okay, so this is called a remapping pin. Okay, is it okay in the class? Okay, so others we go through it later. Okay. So and again, it's a Harvard architecture. This is a PIC24 block diagram. Okay, you can see what is the size of the memory here. Until how many F here? How many bits? 1, 2, 3, 4, 5, 6. It's 24 bits. Okay, it's a 24 bits. Okay, let's look at this problem. So the question is, sometimes, okay, in one situation, class remember in the final assessment, the final assessment question is a case study question. It's an open-ended question. You got a story. You are asked to draw the flow chart. You're asked to identify a correct microcontroller. Okay. Let's say, look at this example. Chan has been designing a water system to automatically water his lawn. We have constantly raised the bar for Chan in his watering system. And Chan has thus far been successfully meeting the challenges using newer and better PIC products. Okay, he already identified he wants to use PIC product. Okay, means microchip product. So you must remember, under microchip they got hundreds of variants of microcontroller. Chen wants to collect data from his watering system. Using a temperature and humidity data, he has to collect it over a period of time. Chen wants to analyze the data, thus maximize the efficiency of his watering system. In order to do this, Chen needs to collect the data over the period of time, then download the data to the USB thumb drive. He could then analyze the data using his PC. What is your suggestion? Okay, you want to download the data. You want to have all these features. Which microcontroller suits in this design? So luckily, microchip got something called microchip maps. Okay, what is so interesting in these microchip maps? Okay, class. Again, my mission here is not to teach you microchip. Okay, so actually my expertise is AT89S8253 because I'm very good on that. Okay, I've just exposed to this microchip when I asked to teach this subject. So therefore, I will go deep and analyze this chip. Of course, this chip got pros and cons. Okay, let's have a look, of these maps. Okay, come to here. Okay, so what you want to do? Okay, I'm selecting microcontroller, microprocessor. This is a very useful features. Okay, let's say for example you want to find the correct microcontroller for your design. Then you can always click all these things. He give you the result. Which one is more suitable for you? Let's say for example, I want to choose a 16-bit microcontroller. Okay, then there's so many versions of 16-bit of microcontroller. Okay, let's say I'm choose a PIC24. Okay, let's say I don't know which one. So CPU type, I just want a 16-bit. Okay, then you can select what operating voltage, how many size you want, need ADC or not, how many ADC do you need. Okay, you just click all this information. Okay, then they will come out and match it for you. What is the size that is what is really suitable for you in your design. So over here, they give you all the development tools that you need, all the technical document of that related microcontroller that you choose. Okay, and all the budget, how much it charge you if you come buy in bulk. Okay, so remember, this is just a microcontroller. Okay, you're not purchasing development board. Okay, remember this. Okay, so like for example, Expressive, they just produce a ESP32 microcontroller. So another company like SparkFun, DoIt, okay, they're purchasing this chip and develop their development board and sell it to you. Okay, is it all right, class? Okay, let's come back to this. So this is a very useful link. Okay, and of course, other microcontroller like STM, they also have something similar. Okay, always don't lock yourself, and lock yourself just use microchip. Remember, there's other microcontroller out there. Although microchip is one of the most popular microcontroller in the market. Okay, let's look at something more technical now. Okay, power on reset and power on reset with the bounce. So this one actually is to test your understanding of circuits. You already learned circuit theory, and you also learn circuit signal and system. Correct or not? Okay, so they got two circuits over here. Okay, so definitely they got few interesting things that you need to be look into. Okay, first let's look at the power on reset. When power on, can you tell me what happened to the MCLR? High or low? Yes, from the floor. When power on, the MCLR is high or low? Why high? Capacitor is not fully charged. So this is ground. It's low. Ayo, I'm so scared now. Low or high? High, man. There's a capacitor here. Capacitor only fully charged when, this will charge up the capacitor. When fully charged, only this will be open. Yes or no? Okay, so this means that the reason of this capacitor 1 microfarad, I cannot simply choose one, So I need to refer to the data sheet and identify how long should it be low, then you consider the system is reset. Low for how long? Let's say, for example, this will charge up until 3.3 volt here. Okay, this is okay. So this region means I consider low, reset 0. Okay, so you check the data sheet. So I make sure that the capacitor able to hold this time. This time is very, very important. So based on the calculation, 1 microfarad is the best solution. Why? Because it can hold it low for a certain time, so that the microcontroller is really being reset. Okay, is it clear or not? Okay, so I hope everything is clear class. So let me clean this. Let me clean this. How to clean this? Okay. So class, please look at this carefully. Because you are already final year, so this means that you can, when you come to embedded system design, means that your circuit theory, your analog circuit design, you know where to put capacitor, how to use op-amp, how to use thyristor, how to use power transistor, how to use JFET, MOSFET, BJT, all these things are okay, because you are not only learning how to write the program, you have to learn how to construct hardware as well. Okay, So I found that a lot of students burn their circuit because they don't know how to look at the electrical characteristics or the features of the component that you connected and the electrical characteristics of the microcontroller that you are using. Okay, so please be careful in all this and remember, always think like this. Let's say today I teach you microchip, PIC24. I teach you all the electrical characteristics of that particular microcontroller. Then next day, you go out to industry, you work under STM microcontroller. You're using FTM microcontroller. So you don't always assume that whatever inside microchip can be applied in STM microcontroller. You still have to look at the data sheet. I will teach you how to look at the data sheet clearly. Okay. So there's another interesting pin over here is called voltage regulator and the VDD core. Okay, these two pin is very important. Okay, so remember, actually microcontroller inside got a microprocessor. This microprocessor only can accept 2.5 volt and not 3.3 volt. So definitely we need to enable this particular regulator. So to enable this voltage regulator means that regulator is enabled by hardware by connected this to ground. Okay. Once this is enabled, you are telling the microcontroller, the microprocessor is operating as 2.5 volt. Okay. This indirectly will link it to something called BOR, brown out. Brown out voltage. How? Brown out voltage. Class, I hope that you are making notes for yourself as well. So, okay, in PIC18, brown out voltage can be set through config register. In PIC24, brown out voltage is fixed at 2.5 volt. What is this brown out voltage? Okay, brown out voltage means is this: if the operating voltage of this microcontroller drop below 2.5 volt, it will auto reset. Okay, you will go into the reset state. Okay, those there when using PIC18, I believe PIC18 you are using 5 volt. Am I right or not? Can you tell me that PIC18 is 5 volt or 3.3 volt? Yes, class. When you're using PIC18, you connect your VCC to 5 volt, your VDD to 5 volt or 3.3 volt. So remember, PIC24 is all 3.3 volt. 5 volt, yes. So in the 5 volt, go back, okay, PIC18. PIC18 got a lot of config register. Config 1, config 2. And please have a look. There's one section they call BORV to let you select 3 volt, 4.2 volt or something like that. If means what? It means if your operating voltage is dropped below this value that you set in the config register, it will auto reset. Okay, but however, for PIC24, you're not allowed to do this. Okay, but the BOR is auto set to 2.5 volt. Okay, why 2.5? Why is BOR? BOR is just to allow you as a user to set why I connect 10 picofarad here. Let's go and have a look. So let's go to the data sheets. So data sheet is very, very important, class. Okay, so this is our on-chip voltage regulator. Okay, They got a few version of connection. So voltage regulator is this is enable. So this is our choice. Why cannot write one? Okay. Voltage regulator disable. If disable, are you sure you want to connect 2.5 volt over here? You're not going to do this, correct? 3.3 volt, then another 2.5 volt. You want to connect voltage resistor, you know? You want to connect few resistor to do a voltage divider, man. You don't not going to do this. Or disable, you want to make sure that everything is 2.5 volt. Then if you put 2.5 volt, how about if your microcontroller input output pin need 3.3 volt? You're not able to achieve it. So therefore, this recommended things is this connection, 10 microfarad typical and 3.3 volt. Okay. Class, ask yourself. Let's say you are connecting your ESP32 microcontroller, the ESP WROOM32, okay, to your target board. Okay, now of course you don't bother because you are using it for doing application. So if you want to create your own development board, you need to identify all these mini electrical characteristics. Okay, so all these features is very important. Okay, so this means that when you do any connection, section 26.1, the DC characteristic is very important. This is a VDD core. I see. We show you that, you know, where is the best operating voltage. Okay, so class, remember, this is very important. Okay, we'll come to this later in future. Okay, we come back to this. So this is the connection. Okay, then how about power on reset? These are the power on reset. Sometimes, you know, in ESP32, we prefer this we press, then it reset law. Correct? We press, the reset law. Class again. If I don't press, what is MCLR? High or low? MCLR high lah, because 5 volt VDD or direct connected there This already fully charged Okay, already fully charged Okay, so in this case there's a lot of connections over here. Basically, can you tell me what is C3 for just now? What is C3? C1 here. Why you need a capacitor? Normally, what is the function? What is the features of the capacitor? C3 or C1? C1 or C3? Okay, what is the features or function of the capacitor? So basically, C1 and C3 is to maintain the stability of the peak internal voltage regulator. Okay, is to maintain, stabilize, maintain the stability of the peak internal voltage regulator. Okay. Can anyone tell me what is the purpose of C2, C5? Yes. What is the purpose of C2 and C5? Yes, anyone? Of course, this one actually is solve the debouncing problem. Debouncing problem can be solved using hardware, using RC circuit. Okay, you can solve by using SR flip-flop. I hope that you still remember. But remember, in our lab assignment one, you are not allowed to use hardware to solve it. So normally debouncing can be solved by hardware. Hardware, we are using RC circuit, SR flip-flop, CMOS inverter 4050, okay, and so on. There's so many types of way of solving this debouncing problem. Okay, you can solve by using software as well. Just put a delay. Of course, this is cheaper lah. This one is all money ma, correct? Okay, but why don't you software to solve it? Can't ma, because this is a reset circuit. How can you software to solve it? Okay, okay. So what is the purpose of all this? You put and C2 and C5. Okay, of course, this C2 another purpose is to solve the debouncing problem. Okay, so basically this is what we call like C2 and C5. We also call this as a decoupling capacitor. Okay, so and actually it assists in supplying transient current needs caused by the high frequency digital switching. Sometimes you will have a very unstable, your current is unstable. Basically this is just to supply a transient current. Okay, so this is a quite just to stability purpose or act as a decoupling capacitor. So basically this is a decoupling capacitor. Okay, is it all right, class? So this means that before I press this is high. When I press, you go low. Okay, low, you go low. Okay, go low. I press this, go low. Low ma, correct? When once you release, you take time, for it, you go back to high. So that's the reason this capacitor actually is to hold it for a while as well. Okay, is it all right, class? Okay, let's move on. So and then power on reset, power on reset definitely, class. When power is applied, you don't want the program to start during this time, crazy man, to start at this time. So make sure it's stabilized, then only reset. Okay. Okay, class, remember this. External crystal is not very stable. It's not very stable, but accurate. Those there, when you are learning PIC 18, you're using external crystal or internal oscillator frequency. Can you tell me external or internal? External. So what is the frequency you're using? Okay, external. External means it's not very stable. Using external crystal consume more power. Okay, but of course the beauty of PIC 24, you do not need any crystal. You can use external if you want higher megahertz. So PIC 24 already built in 8 megahertz. Okay, this is built in already. So you can, by using a PLL, I think you can go up to 16 megahertz or 32 megahertz. It depends on which variant of PIC 24. Okay. Okay, but if you're using internal FRC, it's very stable, but not as accurate as external crystal. Therefore, calibration is needed. Just for information, PIC 24, we always prefer using internal FRC. But however, if you want to use external crystal, because external crystal give you higher frequency, okay? And remember, external crystal also very stable. Okay, not stable, but very accurate. I always mix up with this word. Okay, remember this. Okay, we move on. We'll look into a lot of features, later. Okay. So reset button. So what will cause the system to be reset? You reset instruction. You can call reset instruction. Reset yourself. MCLR. You press reset then reset Okay. Okay. Reset lor. Glitch actually is just like solving the debouncing some spike problem. And then watchdog timer also can cause a reset. We look into watchdog timer later. So it can cause a reset. Power on reset also can cause reset. Brown out reset, just now I told you, if drop below 2.5 volt in peak 24, reset BOR reset okay. Of course, but you must enable the voltage regulator because this had to be connected a voltage regulator just now. Okay, enable this okay. And other things will cause the system to reset is first is a trap conflict. Okay, trap conflict means like example oscillator failure, stack error. Okay, means that the hardware itself got it can't handle an interrupt. So this is called a trap conflict. Like suddenly oscillator is failed, so they will cause the system to reset. Reset actually is to protect your system So illegal opcode. Illegal opcode means that example like the stack is corrupted stack corrupted okay, pointer in incorrect pointer all these things is illegal opcode. Okay, so cause the system to hang. Once hang, you reset itself. Okay, but no worry, whenever actually it's happened to any microcontroller, trap conflict, illegal opcode. Whenever something wrong, let's say for example the first version of development board is released, okay, then you switch on power, you test it. Why keep on restart? It's just like a computer sometimes keep on restart. Restart got so many reasons. Probably it's overheated, all these things. Okay, but the interesting of PIC24, he have a features. Okay, they got a special function register to identify what causing this system to be reset. Okay, so actually this is located in the RCON register. I already told you, I teach you a lot of things today. RCON register. Okay, you can go to PIC24 and just type RCON. So many RCON. Is it RCON? This RCON register. Where is RCON? Okay, RCON register. You see, when your system reset, you can always trace back. When this bit is being set, then you know that it's a trap conflict reset occur. Why my system keep on reset? Then you identify, what causing this reset. Like when this one set to 1, you check, go back and check. It's 1. Something wrong with my power, my brown out, or probably my circuit, didn't supply enough 2.5 volt to the system. Like of course, power on reset, definitely power on reset is set to 1, correct? And you on this one always 1. Okay, this one is always 1. Okay, power on reset. Whenever you on this, your power on reset. You don't believe me? You purposely set this POR to 0. Then you reset a system. This one will go to 1 automatically. You think he said all the reset status may be set or cleared by software. Setting one of these bits does not cause device to reset. Okay, of course, it's set to 1 doesn't cause it reset Okay, so you just go through all this This is some of the information in the RCON register. Okay, this is a status bit. POR, trap, all these things, illegal opcode. Okay, so that you can identify what caused your system to be unstable and reset by itself. Okay, just like your Windows suddenly blue screen come out, and you got submit something you come out, submit this thing to the Microsoft for checking, correct or not? I don't know whether they to check or not, something like that. So here are the features to cause the system to be reset. Okay, okay. So of course, I told you already, PIC24 is divided by 2. FCYC divided by 2, divided by 4, divided by 12. And of course, how to how to manage the config, no problem lah. Actually, we are using Pragma lah. Okay, so let's look into all the bits, into this config 1 and config 2. Okay, so sorry, class, I'm jumping back to our data sheets again. Okay, we go in. I believe that I already told you. We're coming back to this again during the lab section. So all this config register, we will look into it in details now, every single bit. Okay, why this is important? Because config register is a setting, for your microcontroller before you go into the main program. Okay, so this is very important. Okay, so one of the first bit is called IESO bit. Okay, you can read that. IESO bit means what? Normally, okay, IESO means dual startup. You got dual startup. Okay, this is this bit. This bit. This bit. Dual startup. 2-speed startup. Okay, this one, listen, class, there are a lot of words. I'm not going to read this. Class, this one is only applicable if you got using external crystals. Do you remember just now I told you that crystal take times to be stabilized? When you switch on your power, crystal will oscillate until he's stable down. Okay, according to the study, he will take about 124 pulses, before it's stable down. So this means that you on off for 1024 times. If on off 1024 times means your system will you take up a lot of power. Okay, so if this IESO is activated, when you switch on the power, he's not going to use the external oscillator to start up. He used the internal FRC. Okay, then only they will start again, move back to the 124 pulses. Okay, is it all right or not, class? See, when they come out from you, not immediately start operating, have to wait. Okay, become stable. This is 1024 pulses. The problem is very often if a few instructions are performed before micro and set up to the sleep mode again. Okay, like sometimes even worse, when you start up, take quite some time. 124 pulses for microcontroller is quite long. Okay, so what do? You're using this one is they're using an IESO to solve this problem lah. Okay, so another, where is the pulses? Why I can't see it? I thought I got. Actually, this should become first. Like example, is it? You take, crystal startup time take long time to stabilize. Okay, okay. So another problem is this in the sleep mode. Because we are talking about timer. Okay, because we're talking about dual startup. Another things you should look into is the sleep mode. So sleep mode is what? Like for example, you guys now listening to my lecture, probably you're already into the sleep mode. Okay, sleep mode is worse than idle mode. Sleep mode, idle mode, you close your eye and listening. Sleep mode, you are totally lost. When you're totally lost, means that it's very difficult to start up. Just like sometime you put your computer into sleep mode, you sleep forever, bye-bye. The whole system is really in deep sleep, hang. Okay? So, but remember, actually, same with microcontroller, when the microcontroller is sleep mode, it's very difficult, for him to wake up. Okay? So that's why a lot of consideration, okay, need to look into. So luckily, still remember just now ESP32, he got a very tiny real-time clock, tiny crystal to help him. Okay, so remember this. So this is totally different technique, different design technique. So remember, more time is required to achieve stable oscillation. Also remember that. low voltage, high temperature, and lower frequency clock mode also impose limitation on the loop gain, which in turn affect the startup. Okay, so startup slow is not only affected by the oscillator, just now remember 1024 pulses. It also can cause by this, like for example, low frequency design. Of course, if it's low frequency, it takes time, to wake up, from sleep mode. Quiet environment, like for example, now you're at home, very quiet, you take time to wake up. Okay, like battery operated device. Away from noisy environment, if shielded, also take time to wake up. Low voltage, high temperature, like high temperature is very high temperature, very hot. Just like when you're very hot at home, you tend to be more sleepy than very cold. Okay, so all these things, will increase the startup time. Okay, wake up from sleep mode as well, so this is you slow down the startup time. Okay, however, circuit noise is good. You kickstart the oscillator and help to lower the oscillator startup time. Just like for example, now it's time's up, correct? I shouted at you. It's better, correct? You oh yeah, someone is shouting at me, all right or not? So remember all these things, all these features here, you increase the startup time, including sleep mode. Okay, remember when you're in sleep mode means that it might take forever for you to wake up. Okay, so okay, we continue this Friday. So okay, I think that's all. Somebody of you got class. Any other questions? So I will be here. You may ask questions. Okay, class, no worry, because whatever I scribble on the screen, I will post it to you. Okay, I will put it in the Facebook after this. Okay, class, is it everything okay? Any questions? If no question, that's all. Let's hold on. Let me take the attendance. Hold on. Take the attendance. Yes, class. Any questions?